Ball screw, high accuracy mechanical engineering artwork. How Emerson uses technology in Bettis electric actuators. In our last session, we talked about how a ball screw is a high efficiency solution. We covered three topics. The first one was the difference between the Acme and ball screw technology. Then the importance of efficiency, and finally we covered the importance of including high efficiency elements in Emerson actuators, which help to reduce motor sizing, increase torque thrust capability, and add mechanical fail-safe function. At the end of the day, it is what it is, and we will cover the high accuracy feature in this short video. Why is ball screw a high accuracy solution? Firstly, it is important to understand where the accuracy comes from and how a ball screw mechanisms works around it. Sometimes we will have a system attached to a ball screw, a system with mechanical and electronic part inside which has an intrinsic level of accuracy and reliability. So, in general, a mechanical device like gears or ball screws will be used for three main reasons. First, to change the type of output force, linear, rotational, or both. Second, to increase or reduce that force. And the third, to increase or reduce the speed. Depending on the mechanical device attached, the level of accuracy of the whole solution will be maintained or reduced. But everything has a side consequence, and in this situation, mechanical engineers call it backlash. So, what is backlash? Backlash is a clearance or a lost motion in a mechanism caused by gaps between the parts. As an example, a CNC machine tools require ball screws with zero axial backlash and minimal elastic deformation. The technology used by our third-party ball screw supplier has zero backlash because they use Gothic arc form at the ball track and the preload. It is also important to know that excessive preload increases friction torque during the operation, which will reduce efficiency and life expectancy. This special design and fabrication process provide optimized ball screws with no backlash and less heat loss. Now that you understand it, we can confirm that the ball screw design will maintain high accuracy levels of the system and we are ready to go. I would love to show you a backlash, but we will need special tools to measure arc minute change, and I don't have it with me at this time. In this short video, you can see what I am talking about. When the bearings are relatively small, there will be backlash and the nut will tend to vibrate back and forth as it moves in reciprocating motion. In contrast, when the bearings have a relatively large diameter, there will not be any backlash and there will be preload. In this case, there won't be any vibration. Now, in real life, you can see how smooth the movement is with preload bearings and zero backlash. Why is it important for Emerson actuators? There is one important factor associated with the ball screw, zero backlash and the high accuracy of the actuators. And RTS actuators control the speed of its brushless DC motor, which allows it to reduce the speed of the actuator when it reaches the desired set point. This specific feature plus the ball screw allows the actuator to increase the power of actuators and keeps the accuracy at 0.1%. This is one of the reasons that the RTS actuators performs well on most of the modulating applications, which also have high torque and thrust demand. In our next session, I will explain to you the importance of high reliability and how it is important for actuators valve. So I don't have anything more to say. That thank you very much.